Okay, so back to this breakdown once again here. I'm going to say this several times. I'm going to walk you through this, but really what you want to know about cellular respiration is you want to make sure you know this chart here. And I know that it seems like there's a good deal of information on this chart, and you might have trouble trying to remember all this. There are ways you can do that. I know that I'm the big believer in note cards, and I've taught you how to use those note cards, or try to at least to use those note cards to study, where you go through and you write your stuff on them and you flip through and you try to write what's on the back. That I think works very well, but there are times that there are other little tricks you can do. For example, on this kind of thing where you have lots of information and it's organized in a particular order. It has order to it, so you can't just memorize the things. You have to kind of know the order of it. You can come up with little mnemonics or sayings, and you can kind of come up with whatever you want, and you can remember this whole thing that way. So for example, what we do is, let's say the word glycolysis here, the G could stand for good. So good people, and then whatever the K and the E stand for, you can make up your own. It doesn't even have to make sense. Good people can, even though can is supposed to be with a C, you can, spell it with a K. It doesn't really matter. As long as you kind of have some kind of rule like that. Good people can whatever you want. Energy, accept, but once again, accept with an A. It doesn't really matter. As long as you can have some kind of phrase that will help you remember the order, and you could do it with all these molecules as well here. Come up with your own mnemonic, and that's also a useful way to remember large amounts of information, because then what you're learning, really, you're thinking about it as a sentence. You're learning like one sentence. Good King Philip. King Philip came over for good spaghetti. That's a popular one, for example, for memorizing the kingdom, phylum, family. Good, now I got to do it. King Philip, kingdom, and then Philip, phylum, came, that's class, over, order, and so you can do it that way, and that's an organization for the levels of life. But you can do the same thing with this kind of thing. So what we're going to do now, I'm going to go through glycolysis, and then I'm going to talk about the PDC, and then the Krebs cycle and the electron transport chain. So glycolysis, PDC, which stands for the pyruvate dehydrogenase complex, or PDC, Krebs cycle, and then the ETC, also called the electron transport chain. So this is the first step. This is glycolysis. So over here you see your glucose, right? So there's your glucose molecule right there. You've seen that before. And you'll notice up here we have this enzyme called hexokinase. Hexokinase is going to take that glucose, bind to the hexokinase, and that's going to give you glucose 6-phosphate. That takes up a little bit of ATP to do that. Then in the second reaction, phosphoglucose isomerase is going to take that glucose 6-phosphate and convert that into fructose 6-phosphate. So you notice there, and then after that we use a little bit of ATP. So you notice that as we do this, as we go through this series of reactions, what you get is a whole bunch of reactions. You get enzymes that are running each one of those reactions, basically, and sometimes you're using up ATP, and sometimes you get ATP out of that. And you'll notice over here, we'll talk about this NAD, NADH molecule in a second, carrying these two electrons. But once again, this shows you sort of some of the complexity, and this is just the first step. This is just glycolysis. So rather than try to memorize all this, we're going to just narrow it down into what goes in and what comes out, and then the other things that'll come out, like we'll talk about ATP and so forth in here in this NADH. Okay, so I'm gonna show you the whole thing like this, but what you really need to know are just the steps as we go through it, as to what goes in and what comes out, and what the main goal of that set of reactions are. Now, I told you I would talk about this NAD, NADH molecule here. So NAD plus and NADH are really the same molecule, one and the same. What happens is NAD plus, if you look at them, they're very, very similar, but there's the difference right there. Okay, so here's NAD plus, here's NADH. Has that extra bond. Notice this one's got 3 double bonds up here. That's what those are. Down here you have 2 because you've picked up a hydrogen along with the electrons with that. There. And the reason that's important, what's happening is we're taking that glucose molecule, and as enzymes break down that glucose molecule, the energy that's stored in the covalent bonds, which again is the sharing of the electrons, some of that energy you can transfer with the electron. And so what happens is we're taking NAD plus, which is sort of an energy poor molecule, we're transferring some of that glucose energy as we break it down, and that then becomes NADH. So NADH, you can think of NADH as a molecule that's holding on to high energy electrons. When it loses its high energy electrons, it goes back to the NAD plus state. So these are really the same molecule in a sense, but one is holding on to high energy electrons and the other is not. It's kind of like ADP and ATP. ADP and ATP are almost exactly the same molecule, except that ATP has that third phosphate with a lot of energy stored up in the bond in that, and ADP only has 2. So same idea other than that. Okay? Now, so what we're doing once again in glycolysis, we're taking glucose, and we're taking that glucose and we're going to break it down. And as we do that, what's important is we're making NADH, which is what I just showed you, and what comes out of that is pyruvic acid. So by the time we're done with all the steps in glycolysis, what we've essentially done, we've taken glucose, we've gotten a little bit of ATP out of it, about 2 molecules or so of ATP. We've made pyruvic acid, which is going to be what we use next in the next set of reactions, and we've made NADH. And this is what's really important, is this NADH, because we're going to use it on the last step. Sometimes you'll see pyruvic acid, or you'll see the word pyruvate, depending on whether the thing is in sort of its acidic state or not, whether it's pyruvic acid or pyruvate. Don't worry too much about the difference between those terms. For us, pyruvic acid and pyruvate, we'll just consider them the same thing. So if you see those terms sort of changed around, that's okay. All right, so that is what you get out of glycolysis. And then we'll take a break, and then from here, we'll talk about what happens in the second step.